Okay, dear students, Assalamu alaikum. This is the lecture number 21 of Database Fall 2019 semester. So, we will start a new chapter name called Index. So, what is basically the index is? If you are reading ever a hardcover book, you will find a index in the front of your book in some pages, where from there you are getting the topics by which you want to read. That is basically mentioning some the searching parameters, that is the chapter name or the topic name, and some page number, that is called the references. So basically, in the indexing chapter, we are seeing that there are two things basically. One is the search key, the attributes of set of attributes, that is lookup records in a file, and index, from where we are searching the values. Especially here, there are two things. One is search key, by which value you will search the parameter from the database to achieve the data, and in where this data is locating in the database, that is called the pointer. So index files are typically much smaller than the original file, as it is a chapter may be mentioned just in a line, that is chapter number 6 is you are locating in 123 page. So it is very smaller than the whole chapter, right? So index are always the smaller files, but there are basically two kinds of index. One is ordered index, and another type is hash index. So in this chapter we will only read the ordered index, because hash index have some different types of algorithms and these sort of things, and I believe you are already learning the hashing and other algorithms in the data structure classes and algorithm classes, so that is already covered, I hope. So in the ordered index, why we are using the index and how the index is evaluated. So basically we are evaluate the matrix, evaluate the indexes as how fast they are working, how efficiency they are. That is basically depend on the access time, insertion time, deletion time, and space overhead. Basically, whenever you are searching for the data in a database, that is the access time, how much time you have required to searching a data. Insertion time, when you want to insert a data, how it is rational or how it is needed the time. Suppose you want to fill up a form for a national ID card in online, so how many fields you have to give in the database from the data. And now you think, if the database is already synchronized like that, if you put your father's NID number, national ID card number, in the website, and the rest of the information is automatically comes from the database, and also your mother's NID number, so you need not to type your father's name, his last name, first name, or his address, or his phone number, and other information. That is automatically connected from the database. So that is the insertion time. How can we reduce the insertion time? Same as the deletion time. If we want to delete some data, if the data is connected with other data or not, if it is connected with the other data, how many time we does required. And space overhead, that are we keeping the same data again or again, yes or no, that is the space overhead. So if you have collected so many data and the data is redundant, so your space overhead is getting higher day by day. So in the ordered index, basically we will go for two types of index. One is the primary index and another is a secondary index. So the primary index is so far is also called the clustering index, because it is working sequentially order. Suppose like 1, 2, 3, 4. In a book we will find the chapter 1, chapter 2, chapter 3 in a sequential order. We can say it is a primary index. In a secondary index, it is also called the non-clustering index, which is also follow some rules, some order, but it is not in the sequential. Suppose like if you are going a book, in the last side you will find some appendix, suppose A, B, C, D. So these sort of words, suppose A by A, some words starting with A can be found in 96 page, some word can be found in 24 number page. So the serial is not sequentially maintained by the page number, it is maintained through some other aspects. So that is the secondary index. So okay, we'll start from the dense index. So in a primary index, it is basically having also called the dense index files. So basically index is a file. Database, in the database the data are recorded in some places, and for make it a simpler form or making a simpler searching analogy, we have to create another file. It is called the index file. So index files is separated from the main database or main table. So if we looking some a book example, it is an example from a book instructor table. There are so many datas there. So basically here the some datas are here. That is, one is they have some IDs, they have some their name and their department and their salaries. So each of the table in blue color, the table each contains the instructor ID, instructor name, instructor department and instructor salary. These 4 types of data, and for each of the data you will find a index value. That is the index value. It is we call so for the search key by which we will search the data, and this is the pointer from where it is pointing the row of the data where it is located. So it is called the dense index file. For dense index, for each of the row you should have a single search key. For if you have more than 1000 data, there will be 1000 search key in the dense index file. So that is the policy of the dense index file. Now we will go that is another example of the dense index file. We will deploy it through its department's name. Suppose in the whenever we are making a file, it is always a as it is a primary index, so it is always in sequential. So you see here that is it is started from B, then C, then E, then F, H, M and P. So it is maintaining a alphabetic serial. So the thing is that the biology department, it having one faculty, so that is it is selecting one rows, where is the computer science having the 3 faculty members. So 10101, 455, 65 and 83821, these 3 faculty members are from the computer science department though. So one pointer is pointed to the first row of the same type of data, and then electrical engineering is started after the computer science department has completed. So this is how the dense index is managed. Okay, so in the sparse index is another type of indexing, where for the sparse it is means that it having some only some values we will keep in the indexing file, not all the values. In the dense index files, for each of the record we will preserve a value in the index file, but in the sparse index file we will just keep some random values in the index files, where we are indicating or evaluating the each of the values which will be is bigger or smaller from that. Suppose like if we having some data like this, the same file, the blue color table, it is having the instructor table, it's having some ID, their name, their department and their salary. Whereas in the sparse index you will get only 3 values in the index file, not all the lines, not all the values, because it is one of the policy here. it is started with some values, that is 10101, that is in the first line, and after that a random value is picked from 32343. So if we search a value like 15151, this value, so we'll compare with the first value with 10101. So is the 10101 is lesser than 15151? Yes. So we will need to proceed the next value. If the 32343 is less than 15151, no. So the 15151 is lesser value than 32343. So it is found in between of 10101 and 32343. So this is how the searching is doing here in the sparse index files. So this is it is taking some random values, and it is not mentioned that is you have to take the first or the last values, but you always having some comparison with the largest searches value is less than k what will we are preserving in the search key or in the index files. So in the sparse index, there is a trade-off between the sparse index and dense index, as dense index required some big space, because all of the record needs a search key, so it required more place in insertion and deletion, but it works first in the dense index. But in the sparse index file, as it is comparing with one another, but it having some less values, so insertion and deletion, it requires less space in the file, but it required more time to calculate, because each of the step is calculating, each of the step is comparing with the other values. So that is a good trade-off between the sparse index and dense index files. Okay, now we'll come to the secondary indexes. Secondary indexes, in the secondary indexes, what we can find is, suppose if you want to make the instructor relation not sequentially, you want to search with their IDs, you want to search with their particular department, or you want to search them with their salary. So whenever you are searching them with their salary, same salary may have multiple persons. Okay, in a department or in a university, maybe more than 10 or 20 faculties can be get the same salary. So these all values are not in the same row, because a index file having some sequential order, either whatever the sequential is sequence is, but it definitely maintains some sequential order. So if you have the same value for 20%, or if you have the same value for the 20% for the same department, so how can you manage these things? So that is why it is required the secondary indexes. Secondary indexes is basically creating a layer between two index to the main table. Basically it is creating extra layer for, because it is maintaining same type of values for different persons. So if we go for an example, suppose like that, if you want to searching parameters, or if you index with their values with their salary, then you will find the salaries are in a sequential order, though the salary are not same for the same persons, but it is indicated another value that is a index, and this refers to the main table, that is another index. So they are creating two layers. As it is creating two layers for the indexing, so we can say it is a secondary index. The secondary index always creating two layers. There is a first layer having some different type of values, which is not the primary key or something like that, and in the second layer it is connected with the main mother table, that is creating some bucket, and that contains the pointer to the all actual records with the particular search key values. So secondary indexes have to be the dense, always. Okay, so the difference between the primary and secondary index is the primary index is obviously having some beneficials, that is in the searching or the recording, but whenever you have in the and always the secondary index is expensive because there are two layers. So primary index is less expensive than the secondary, but in the searching or different type of modification or updatation, you must have to need sometimes the secondary indexes, though it is having much expense than the primary index. So that is another type of index is multi-level indexing. So in the multi-level indexing, when the primary index is not working properly in your memory, in your database, so you have to create secondary index, but you can make a system that is you can create two layers or layer by layer indexing. For that, in the outer level, in the outer layer, you will keep your index as a sparse index, that is you are picking some random values from your indexing files, and the inner index you will obviously maintain a dense index for all the recorded. So this is how your outer index is not always large. It is space overhead is less because you are using the sparse index, but it having some more calculation time if the index is growing large. But in the main memory, in the inner index, you are using the primary index, so space overhead, though it is going high, but it is usually search with the fast technology. So that is the multi-level index. So for your multi-level index, there here the outer, there are three levels basically, outer index, inner index, and your data. So outer index, in the outer index you will just choose the sparse index, that is some random data 1 2 3 4 or something like that from the different blocks of the inner index. From the outer index, you are comparing with some data, and then you are selecting the data will be found in which inner index, block 1 or block 2 or something like that. From the inner index, you will then again find in which table I will get these data which are in the blue color. So that is the multi-level index concept of the indexing. So the how can you delete or how can you update some data? So index, so if it is a dense index, for dense index each of the record having some index file always persist in the index file, so you must have to delete the data from the database and also from the index. But in the sparse index files, all the data, all the key fields, search key fields which are in the mother table that are not belongs in the search in the index files. So if the data is belongs in the search key or the in the index files, you have to delete from there and also in the from the mother file. But if the value is not in the sparse index, then you just only deleted the value from the main database, so that is enough. And if you want to insert, so for dense index, it is obviously understandable that all the data in the main table should have the search key in the dense index in the index files also. So if you insert some data in the database, so the primary key will be inserted in the also in the search key value or in the index files. And in the sparse index, if you insert a value in the database table, if the range is already persist in the search key ranges, then you need not to add some values in this the sparse key. But if it is so many large for finding out, you can pick some random values in between from the range and put it in the sparse index as if it is not already large, so the space overhead is going to be large, but the number of comparison will be lesser, so your computation time will be lesser than the primary file. So this is how the sparse index is inserted. So that is the end of today's lecture. Thank you.